Welcome to this demo of configuring NVMe over TCP with VMware by Broadcom and VAST data. There are many pillars in the VAST AI operating system, and for the sake of this demo, we're going to discuss the data store pillar, the pillar that enables us to create data on the AI operating system itself. Now let's go ahead and configure what needs to be configured, the VAST UI. So you can see I have the user interface, and I have the single tenant configured. So I didn't configure anything special or multi-tenancy on the array itself. And we browse to the view element store, and we're going to create a new view. I'm going to give this new view a name. So it's going to be block 01. I'm going to use the default policy, even though I can assign a new one. And I can also configure a quality of service that is available as a VAST 5.4, but I'm not going to do it now. Now let's give the view a name. So I'm going to call it block 01. And that's about it. Now let's go ahead, and now that I configured the view and gave it a name and chose to use NVMe over TCP with the block, let's go ahead to the volumes tab. And I'm going to create two volumes. I can configure also more volumes or less volume if I want to. Let's go to the multiple volumes option. I'm going to use the policy block 01. And let's give them a suffix name if I want to. I can configure other parameters such as meta, tabs, etc. I'm going to create two volumes. Each one of them is going to be configured with 10 terabyte. So a total of two volumes. Each one of them is 10 terabyte in its size. And again, I have many other parameters that I can configure if I want to, like tagging, etc. But I'm going to skip them for the purpose of this demo. Now that the volumes are being created, I'm going to go ahead and configure the host IQNs. It's like this unique identifier per host. And for me to do that, I need to go back to the ESXi hosts that are configured. So I have two in this lab. I'm going to SSH into each one of them and run the command that will provide me the ability to view the IQN name itself. So this is the command that I'm going to run now. And it's going to come with an output telling me the specific NQN name that I can then configure the VAST AI UI itself. So I'm just going to copy it from the ESXi console, go back to the VAST tab. You can also configure and view the knowledge base articles. So I'm going to go to host and give the host a logical name. I can call it E601 or whatever I want to. And what's important is that in the IQN tab to actually give it a proper name. And so I'm going to call it E601, and I identify the right parameters for this host, and it's configured. So I'm going to repeat this operation at the other E6i host. Same thing, you're going to SSH to the E6i, run this parameter, which will show you the exact identifier, which is of course unique to that host. I'm going to go back to the VAST host tab and create a new host. Same story here. I'm going to call it E602. I'm going to use NVMe over TCP, of course, which is why the TCP is being selected. Going to put the right identifier, the unique one, and that's about it. The hosts are now being configured. The other thing that is very important as part of our best practice that, again, you can view at our website, the public knowledge base article, is to configure a proper virtual switch that will be identified with NVMe over TCP traffic. You also want to create an adapter, a storage adapter at the E6i host, specifically for NVMe over TCP. So you need to add it if it's not being added already. And here you can see that I've already have two of them that I've installed, but I didn't configure. And back to the virtual switch, you want to disaggregate and isolate the NVMe over TCP traffic from the management virtual switch. There are other parameters that are important, like NIC binding, etc., which I'm not going to touch too much now, but you can, of course, again, view them via our best practices guide. You also want to enable jumbo frames and things of that nature that are also very important in the context of virtual switch and routing NVMe over TCP traffic over the Ethernet. So now that I did it, there are other best practices that are important that, again, can be found in our knowledge base website, but just for the sake of this demo, I'm showing it to you here. What's important is to create a PHP adapter. So it's an high-performance adapter that will allow the NVMe over TCP adapter to identify a vast data array that is connected to it with all the best practices, such as load balancing. In our case, we're going to do load balancing via latency-based routing, etc. And so you're just going to copy and paste those commands into each one of your E6i hosts. So it will connect to the vast data array in the best possible shape or form in terms of latency and performance and high availability and all of that important information. So now when I copy the same thing into the second E6 host, and I've already did it on the first one, I'm basically ready. Now that the host are configured, I'm going to go ahead and map the volumes that I created to the host that I configure. So I'm going to select the host and select the manage mapping, which will open up a screen for me so I can view the volume that I want to map. So remember, I created 2 volumes and I want to map each of these 2 volumes to these 2 hosts, which is what I'm doing here. And then I'm going to click the save mapping, which is now mapping those volumes to this host. So the volumes are ready. I can, of course, use the CLI if I want to do that. And now you can see the volumes that have been mapped in the right side of the screen, which shows you the mapping interval itself. And now I'm going to go back to the virtual IPs tab, see everything that is configured in terms of the network access. It's important to get the first virtual IP from the virtual IP pool when I configure the NVMe TCP adapter. So remember, we install this adapter, and what I'm going to go is go to the controller tab in the vCenter UI, add controller, give it the first IP in the VIP pool, select the port number that I configure for this NVMe over TCP traffic and VIP pools. In my case, it's going to be port 8001, 8009, but it can be different ports. I'm going to click the Discover controller. So it's going to discover all the IPs in the virtual IP pool that I created. I'm going to select all of them and click the OK button. And I'm now going to repeat the same thing at the other E6 IOs. So again, the NVMe over TCP adapter, the controller tab, add controller, give it the first IP in the virtual IP pool for that operation, the port number, and discover controller. Click all of them, select all of them, and click the OK button. And now what I can do is actually go ahead and provision the first volume, the first VMFS data store. So as you can see, if I now go to the controller, it will show me all the IQNs and NQNs that have been discovered per the discovery operation. All the paths that are available, we recommend configuring at least 16 IPs in the virtual IP pools for all the traffic to be active and also for high availability purposes. And as you can see, this E6 has only a local data store. I'm going to create this new VMFS data store, clicking Storage, New, VMFS Storage Volume. I'm going to select the first volume, give it a meaningful name, click the Next button, which type of VMFS version, space reclamation known as deallocating the NVMe over TCP world, which is very important when you delete capacity. Click Next, and I'm also going to repeat the same thing on the other volume. What's important to note is what you see here. Because I configured the best practices based on latency, they are now being reflected here. So you can see that the multipathing is configured based the latency parameter and also all the available active paths that were configured via the VIP pool. Thank you for watching. At VAST, we're all about breaking trade-offs, and I hope this video was educational. Please don't forget to visit us at vastdata.com.